Good day, grade 9 science students. Today what we are learning about is circuits again, and we're going to learn how to draw schematic diagrams.
So let's talk about the parts of an electric circuit quickly here. We have our source, which is a battery, okay? And the battery gives the electrons their energy. We have an electric load, which could be like a light bulb, and it changes the electrical energy into heat or light. And then you have a switch, and a switch breaks the circuit and completes the circuit. It turns on the circuit and closes the circuit. So when you flip the light off, you're actually cutting the circuit. When you flip it on, you're turning the light on. The switch allows electrons to pass or not. And finally, we have wires. And the wires are basically made of conductive material, like a metal, and it allows electrons to pass along without changing their energy too much. This is a bit of a lie. In your house, if you got a really long wire, you actually lose a bit of its electrical power because the wire has a little bit of resistance. But most wires are actually pretty good. So we have different symbols for this, and we're going to show you the symbols right now. So a battery looks like this. An electrical load we draw like this. This would represent a light. So you got a bent wire with a circle around it. We have a resistor, which we put a squiggly line with an R saying that it's slowing down electrons. And we have a switch, which is just a broken wire that looks like it's incomplete.
So if we look up schematic diagram on Google, you'll see that you come up with a bunch of different diagrams. Now, every single electrical device that you would own would actually have a schematic diagram for an electrician to fix your electrical device. So if we look here, we got a bunch of different things. This actually represents over here, this represents 1, 2, 3 batteries. And you have a resistor in here. And you also have another type of resistor here, and it looks like the circuit is broken over here. This is just a random looked up schematic diagram. If we look at this schematic diagram down in this corner, you can see that you have a voltmeter hooked up and an ammeter. So the V and A represent voltmeters, and we also have some resistors. And we have a couple of batteries attached to each other in series, end to end. 1 battery, 2 batteries, and we have a switch. So I'm going to show you how to identify all these things and be able to draw schematic diagrams of your own. So another thing we need to know is in this diagram I'm showing you that an ammeter is wired in series, and you can see that it's a straight line right here. So you can look at that and see that it's not breaking the circuit, or it is breaking the circuit. It's sitting right in the middle of it, so it can measure the flow of electrons. Where voltage is always over a load, and it's wired in parallel. So this is a resistor, it looks like right here, and then we have the voltmeter measuring the energy of the electrons before it goes through and after it goes through. So if we look at this diagram right here, this end here, the shorter end, is the negative end, and this is the positive end of a battery. And the electrons travel along here, and then they go into a resistor. And if we measure the volts, or the potential difference before and after, it will decrease because it's losing energy as it goes through that resistor. And then it goes through the ammeter, which measures the amount of electrons, and then finally it goes back to the positive side of the battery. And it continues on forever. Now if we were going to introduce a switch into this, then we could turn it off, but this appears not to have a switch. If we look back at this diagram right here, what we see is that we have a switch located here, and right now the switch is off because it's not completing the circuit. You can see that the pathway has stopped. So nothing would work in this circuit at all. Okay, students, what we're going to show you is a bunch of different symbols that we can use, and some of them we already know. A source is something that provides energy, and this would represent a battery, so this is what we'd have. The short end is the negative end, the big end is the positive end. You have a fuse, which is a control device. Now, control devices, they control the flow of electrons. So this is an example of it should look like that. It controls the flow of electrons. You can also have a load, and a load controls, or what it does is it converts the voltage into something useful. For example, a motor would take voltage and convert it into movement. So we have, again, we know what a load of a light bulb looks like. It has a funny wire here, looks complete like that. We have a resistor, which converts, oftentimes it will convert electrical energy into heat. So, looks like this, squiggly wire, we've seen this already. we can have more than one battery. And if we had more than one battery, we would have them lining up, just like you line up batteries in an electrical device. The positive end, and at this end is the negative end. You can have a circuit breaker, which is going to be a little bit different. A circuit breaker is a control device that's at the bottom of your home, and it looks like this. Okay? We can have a ground connection, which is a connector. So it connects two things together. And a ground connection would be this symbol here. We have an ammeter, which we've talked about already, where you have a positive end and a negative end. And we have a voltmeter, which looks like this. Now a voltmeter, we're going to learn, is connected in parallel, and an ammeter is connected in series. You can also have conducting wire. And conducting wire is a form of a connector, and it is just a straight line. Now a switch we can have is a control device because it turns the electricity flow on and off, and it looks like a broken wire with just coming off there. That is in the off position. And you can also have a connector. If we take a look at a connector, joined wire, and we have a power supply, which is a source. Here it looks like this. And we can also have a clock, which is just represented by a C. So the most important thing that you need to know is these ones here, the ones that I highlighted before. For example, what does a battery look like? What does a light bulb look like? And what does a basic cell look like? Okay, voltmeter and ammeter. So I'll give you this handout. You should fill this out, and I'm just going to learn a few simple rules on how to draw schematic diagrams. So when we draw circuit diagrams, we always want to use a ruler and a pencil. And circuit parts are connected using straight lines. 3 corners are drawn as right angles and no symbols on the corners. And if you can take a look, I've drawn a 3-cell battery, and you can see it's got 3 cells, 1, 2, 3. You can see the path of the electrons, and you got it going through a fuse, to a clock, and then again through a resistor, to a motor, and then finally to a switch, and then back to the 3-cell battery. And this is showing you the direction of electrons. We have another diagram, draw a circuit diagram consisting of a power supply, which is right here. This is a power supply for a motor, okay, and 2 light bulbs. So we have a light bulb going through it to a motor, and we have a voltmeter that's connected in parallel. Parallel means it's in a separate path. And finally back to a circuit breaker, which is right here, and then back to the power supply. This is how to draw a circuit diagram.